see?
Well, what we're expecting to see is what we've seen all week long is that the robotic boats, which are fully autonomous, and for those that are wandering around this great, beautiful public park in South Daytona that may not understand the word autonomy, it means that the boat is going to go out on the pond, it's going to exhibit behaviors without any human control at all. It's very difficult, very complex. But we've had 13 teams here all week long, braving the heat, the showers, but more important, the technology and the challenges of that to try to find out how good they do against a really difficult course of behaviors that would happen out in the real world, on the ocean and lakes and things like that.
So you kind of led me in. My next question is, why do we do this? Why are we suffering through this heat to allow these teams to come out and try this? What do we get here that these teams don't get at the university?
Oh, we're not suffering at all. We love the heat. The heat, the humidity adds just, it's the silver lining in all of this. And it's why we keep coming here in June.
Oh.
But the bottom line is that we brave the elements and deal with sleep deprivation and all the challenges, mainly because this is probably the hardest challenge that these students are going to have in their academic career. And more importantly, it prepares them to go off and take jobs with all of the big companies in industry that are working on autonomy, whether it's drones, driverless cars, boats, or submarines.
Okay, very cool. Well, we are about 3 minutes to 2 minutes out from the first team's time slot. So if there's anything else you'd like to say, you're welcome to. And then we're going to take a moment to pause as we get that team up on deck and start working on their team time.
No, I'm going to stop talking because it's really more fun to watch the boats do their thing. And for those that are wandering around, if you make your way over to the tents on the, what is this, the south side of Reed Canal, the side farthest away from the road?
I believe that's north.
Whichever. So find your way to where the teams are launching their boats and then just listen to the students as they watch these boats go off and do things that the students don't always know what's going to happen. So that in itself is a lot of entertainment.
Very cool. All right, so we're going to take a moment to pause as we get ready for the first team to go on the water. back with Embry-Riddle Aeronautical University, the actual local university, and they are first up in the finals today. And I have someone sitting here with me. Can you go ahead and introduce yourself?
Hello, my name is Patrick Courier. I'm one of the advisors for the Embry-Riddle team and a professor in mechanical engineering.
Okay, so you're actually part of the staff at the university that help put these teams together. What's important that is the reason why these teams come to these competitions?
Well, what they get here is an experience they really don't get in the classroom. In the classroom, you learn a lot of theory, which is extremely valuable. But most people don't really understand that theory till they get a chance to come out here and apply it and see how all those calculations really map to the real life, and find out also that sometimes they don't and it doesn't work.
Ooh, how often is the find out it doesn't work like the laboratory versus it works like the laboratory?
Pretty close to 100% of the time.
It doesn't work?
It doesn't work.
It doesn't work. So that's why these competitions are so important, because it really gets them to break out of that laboratory environment and start thinking that they need to think about other challenges with their solution and what the real world brings in.
Yeah, this is a great preparation for future careers for engineering students, because once you get out of school, you're going to actually be designing, building, developing real systems, and that's what these students are doing out here.
Oh, very cool. So what do you know what your team hopes to look to do for this for these final runs?
We're gonna try probably to come out here and we're gonna try to fly our quad and go over to the raise the flag and see if we can find the number there. We were able to successfully do that in practice. We won't try to land on the boat because the risk of crashing is fairly high, but we should be able to land on the dock autonomously.
Ooh.
And we were able to do it in practice. We'll see what happens. We had a little bit of excitement this morning with a battery in a RC transmitter, so it may fly, it may crash into the lake.
Excitement with a battery. I'm not sure I want to be around to see how exciting that was.
Yeah, you didn't.
Okay. So just so we're clear, so what he was talking about is those spectators that can see out into the water right now, the little square dock that has the 1, 2, 3, and 4 on it, there is a display in the middle of that that's only visible from the top down. So you have to launch a quadcopter and get it to fly over that element in the task, observe that number, and transmit it back to the boat to actually have some sort of action replied from that number. Now, is there a bit of sense of pride being the aeronautical university here that you want to make sure that you can demonstrate the capability?
Yeah, I think there's some motivation there. That it is in our name, so we would like to fly. We were able to successfully fly last year. And we'd like to do it again this year. I don't know how many teams will actually attempt in finals. I know we're not the only ones who are prepared to do it.
Ah, okay. Now, what makes the aeronautical part hard about this challenge?
Really the toughest part about the aeronautical part is launching and recovering on the boat. These boats are only about 4 to 5 feet long, and they're limited to 3 feet wide. By the time you get a quad that's big enough to carry the required sensors, it ends up being nearly as big as the deck of the boat.
Ooh, so it's almost like a system engineering problem. You got a lot of stuff that you have to balance: weight, sensor capability, processing power.
Yeah, you really have to balance all that, and it ends up being that you end up having to land on a platform that is not much bigger than the quad itself. So we actually have a precision landing system that uses an IR beacon. And so the quad can fly out, find the IR beacon, home into it. In practice, we were at least once able to land within an inch of our target.
Wow. I see the boat's now actually doing something. So
It looks like it's headed towards the Find the Path challenge.
Is which challenge it's going to pre-scripted? Like, does your team know ahead of time that's where they want it to go?
Yeah, they're pre-scripting it this year. We have in the past tried to do without that. This year, though, my team focused a lot more on hardware than software, so we're going with a little bit simpler software approach. What it's doing right now is it's doing some recon. It's actually going to go out there and use its Velodyne LiDAR to build a map of the course that then it can use on the future runs to do them more accurately.
Okay. I actually heard a great saying this morning, and I thought you just sort of touched on it right now. I heard software will win this competition, but hardware will lose it for you.
Yeah, that's one of my favorite sayings to the teams.
You're the one that told me.
Because when you come out here and you see, we were this week, we did not have nearly as much time on the water as we would have liked to have had because we had a number of hardware problems, and a lot of them were minor. Some of them were self-inflicted, but because of that, we didn't get much testing time, and that's what it really comes down to out here. If your hardware works, even if it's not the best, you can be competitive. But if you can't get the boat in the water, you can't get it running, you don't have a chance.
Okay. So to be clear to all our spectators watching this, these boats are not RC controlled when they move around here. There is no human controlling this. That's what makes this competition hard, is the boat itself is observing its environment, making decisions, and moving itself around. So we see it looks like you're starting another run here.
And it kind of looks like it might be heading for the speed gate. I'm not sure exactly what order they're going to attempt to do things in.
Let's see. It's a very sleek looking boat.
Yeah, they worked really hard on the boat this year. The thing that's unique about this boat and that you really can't see while it's in the water is the thruster configuration. So if you look at most of the vessels out here, they have usually 2 thrusters that are side by side. Ours has 2 thrusters that are fore and aft. So there's one right about in the middle of the boat sticking down, one right at the aft end of the boat.
Ooh.
And those thrusters can do what we call azimuthing. They can rotate so that the boat can actually even move straight sideways if it needs to. And you'll notice here that we've programmed it with what we call a turbo mode. So you see it slows down when it's doing these tight maneuvers. When it's got a long way to run, it'll goose both thrusters and use the speed that it has.
Very cool. Now I noticed the quad's not on it right now. So do you think they're saving that for maybe one of the later runs?
I believe they are. That was kind of their strategy. They were going to send it out and make a couple of attempts and build that map that we are relying on this year. And then they'll probably bring it back to the dock, put the quad on, and do it.
So you're saying is every run that it takes right now, it's mapping the course, remembering what it saw, and using that for the next run?
Yes, that's exactly what it is doing.
Okay.
The LiDAR is doing the majority of that mapping. We actually borrowed a little bit of technology from our RoboX team to help us do that.
Very cool. So it looked like it completed the speed gates, and now it's heading to find the path. In this task, the robot has to find a way to maneuver around all those obstacle buoys and circle the orange and blue. Ooh, looks like it might have hit an obstacle there.
Yeah, it does
Yeah,
look
maybe another one.
like it is on a buoy seeking mission at the moment.
Uh-oh. I think it's trying to touch everyone it can.
Yeah, the obstacle avoidance is not as well tested as we were hoping to have it. That was one of our goals for this week, was to dial that in, and we had so many hardware problems, we never quite got it perfect. So I would not be surprised to see it hit a few more.
And for those watching, the way this competition is judged is we actually have a fleet, or not a fleet, we have a group of professionals from the autonomous robotic community that are here observing the behavior of this robot. And each run will be counted separately, and then we'll take the best run to judge the performance of the robot. These are all experts in their fields of autonomy, and they're really looking for behaviors and doing their best to observe and rank how well behavior is performed in the robot. So you'll notice them in eagle-eye concentration as they count how many buoys you hit there and work that into your score.
Yeah, I hope the judges are wearing flip-flops today, because it looks like they might need them out there.
Yeah, it is a hot day. So it looks like it finished circling the path, and it's deciding where to go next.
Yeah, I'm not sure what they've got it programmed to do on this run. It's probably not going to attempt to do the raise the flag challenge, because we didn't bring the quad on this run.
Kind of required.
Yeah, otherwise you're just guessing. And we might take a guess at it, but we think we can actually do it and find the number. In practice, we were able to actually get the number, use our computer vision algorithms to analyze the picture and identify whether it was a 1, 2, 3, or 4.
Okay, looks like it's actually coming back to the dock autonomously.
Yes, there are points for returning to the dock autonomously. The judges want to reward you for completing a mission as planned and not just aborting one out in the middle somewhere.
Okay.
The number of points you get are dependent on how many challenges you successfully complete. So right there,
Ooh, we got some applause from the audience.
We probably got an extra 200 points right there for returning to the dock, because we attempted 2 challenges.
All right. Now, again, it's the best run. So they have no worry or risk of going again, because they're going to just keep trying and see if they can get more points. I'm really hoping to see a quad take off.
Yeah, me too.
And you are the Aeronautical University, so you're the best hope of that.
It looks like they're putting the quad on the boat right now. So
oh, awesome.
Given the problems we had with this morning, there's no telling what it may do. It was flying great, and then the transmitter melted. So
sometimes robotics comes down to just luck, right?
Yeah, it may fly. If it crashes, it's going to be due to probably those issues we had this morning with it.
All right. Now, to be clear, all the teams did have to complete a flight safety check and demonstrate to us separately that their system had some robustness to it. But again, sometimes a gremlin just sneak in and a battery may have an exciting night, and then we're not quite sure what we're going to see.
Yeah, so hopefully it flies. They think they fixed it, but they didn't have time to test it again. So we'll see what happens here.
Right.
We have our safety pilot, Pedro, standing by. One thing with being Embry-Riddle, we have no shortage of pilots. But when the quad is actually flying, he's not going to be in control. He's just going to be watching. And if he has to take over at any point, we don't score any more points with the quad.
Okay.
So
Now, are they shooting to try to put the beacon on the dock and have it land there?
yes, they will be putting the beacon on the dock and trying to land on the dock. It's too risky to try to put it on the boat. And if it goes in the water, it does have flotation. If it stays upright, it would probably be okay. We're not too confident if it goes down that that's going to happen. We put one in the lake last year due to an unfortunate gust of wind on takeoff. And we ended up losing pretty much all the electronics on it.
Ooh. With great risk, or great reward comes great risk.
Yes, we're willing to take the risk here in finals and see what happens. Because, well, this is where it's all at. Either you go big or you go home.
That's a good way to put it.
Although, technically, we already are home.
Yes. Now, it looks like, yeah, it's coming out of the dock now with a quad on the back, so.
If it works, it should launch the quad pretty much as soon as it gets in the course. Our strategy is to take advantage of the fact that we have two vehicles. So the boat's not going to sit there and wait on the quad. It's going to launch it, and then looks like it's going to do the speed gate immediately thereafter.
Okay. So again, everyone watching, these robots are driving themselves. It is not a human operating them.
Yeah, and we do not trigger the launch of the quad. The boat actually tells the aircraft when to launch.
Okay.
They are talking to each other, and then the aircraft can transmit images back to the boat, and then we actually use the computer on the boat that's much more powerful to process the image.
Okay, so the processing is done on the boat.
Yes. Yeah, it's hard. It comes into that systems engineering challenge of it's hard to carry a computer powerful enough on the aircraft to do that image processing. So we chose to downsize the aircraft and use what we already had on the boat.
Oh, and we see a launch already.
We do have a launch. I'm not sure that's exactly where they intended to launch it from, but it is flying.
And it is staying up. So far, exactly what we want to see. Now, will the boat have mapped where the 7-segment display should be, and the quad is then fed those coordinates to fly there?
Yes, that's what will happen, is since we've already been out on the course, the boat should have a very accurate position on that 7-segment. Of course, it is in the water, so everything moves a little bit. So the quad should do a little bit of a search pattern over the dock here, over the find the flag here, and so we'll see if it gets over top.
Now, it appears the boat has decided it's going to take a vacation.
It does kind of appear that way. We've also been having another problem related to one electrical issue we haven't been able to fully trace down, where the servos that azimuth the thrusters are sometimes cutting out on us. And when that happens, the boat can no longer control itself. So sometimes those are working and sometimes they're not.
Yep.
We'll get that fixed for next year, but
It does appear the boat's been put back under manual control.
yeah, so I don't know if they're going to let the quad fly out the mission autonomously here, if they're going to have Pedro bring it back in and land it. It's definitely coming back to the dock, but there's no indicator on the quad on whether it's in manual or autonomous control.
Do you have enough energy to go again if you're able to reset?
We should, yes.
Okay.
And we have a spare battery if we need it.
So what are some of the challenges designing a dual domain system like this?
It gets very complex. We ended up basically kind of breaking our team. It looks like it has successfully landed on the dock.
Yay.
Not sure if that was autonomous or manual. But the challenge is really coming. We ended up kind of breaking into two separate groups. So we had one group that focused on the boat, one that focused on the quad. But there's a lot of interaction that has to go back and forth. So this is actually the second boat we built this year. The first one was mostly a test platform, and the quad guys walked in, looked at it, and laughed. So we can't land on that. And so revision 2 of the boat was significantly enlarged to ensure that we had a big enough deck. because we missed that communication on the first round. And then there's also been a lot of back and forth that's had to go between the two groups on how do we communicate? How does the boat tell the quad to launch? How does the quad get the pictures back to the boat?
Right. So it's a systems engineering integration challenge now.
It really is, and these competitions like RoboBoat are really primarily systems engineering problems.
Okay.
We do sometimes develop some new hardware like the thruster setup we have, but it's largely taking off-the-shelf parts, figuring out how to make them work, and putting them together in a system that can actually accomplish the mission.
Okay. And that kind of goes back to the comment, my new favorite line, that it's, software can win you the competition, but hardware loses it for you.
Yeah.
Oh, here we go again.
Quad is up again.
Another takeoff. That was a fast turnaround time.
That was a very fast turnaround. So obviously they didn't change the battery, but we should have about 15 minutes of flight time on the quad.
I mean,
So
we are in Daytona, so I'd hope that your pit time would be pretty fast here.
yeah, we're right next to the Speedway, so we've been practicing.
Oh, and the boat still looks like it's underway. So
All
it
right,
looks
they
like we're
must
gonna
have fixed the servo fault. They have figured out here, we haven't figured out how to fix it, we have figured out how to reset it.
Oh, is it unplug it, plug it back in?
Actually, more or less, except they figured out a software way to do that. So they could trigger a reset, and there it goes. That's gone into turbo mode right there.
I do think you need some flames painted on the boat for that.
Yeah, we'll have to add that for next year. We are intending to bring back this boat next year. That's been the goal all along. And next year, we're really going to focus on the software more and refining the couple of hardware faults that we do have. Focus on the software and also focus on making the deck a little bit better for quad recovery.
Okay.
And it looks like the quad is actually right over the Find the Flag challenge. I have no way to know whether or not it got the picture, but it definitely could have, given where it is at right now. Also looks like we just finished the speed gate challenge.
Yeah.
With a decent turn of speed. We're not the fastest boat here, but
You've done a lot pretty quickly already.
yeah.
Now, if the boat gets the answer from the quad, will it prioritize getting to that element and finishing the task there?
I'm not sure how they have it set up, actually. We debated a little bit there between trying that one, which is a little tough for us because our boat's fairly low compared to the buttons. We basically have to hit the button with our light tower,
Uh-oh.
which risks a little bit of damage to the boat. So it may go try to do find the path first. In fact, that looks like where it's going. You see it shift into turbo mode there?
Yep.
The two modes it has, in tight maneuvering mode, what it does is it turns the forward thruster 90 degrees and uses it for side-to-side motion.
Okay.
In turbo mode, it rotates it back along the long axis of the boat and fires both of them to get speed.
Okay.
So that gives us kind of both benefits of high maneuverability and high speed.
And that's because the teams that have fixed thrusters, you actually lose efficiency when you're turning. But since you can turn your thrusters themselves, you get full efficiency in any direction you want to go.
Yes, that is true. And you can also maintain full speed in any direction you want to go.
Okay. So
And it looks like the quad is attempting to come in for a landing.
Oh, yeah.
I'm not sure if it's still autonomous or if that's Pedro flying at this point.
if I had to guess, I'd probably say autonomous.
Yeah, if he thinks it's going to go in the water, he will save it, but we will lose the point. So he's
Right.
probably going to try to let it come in unless he
Oh.
feels like he can't do it.
And it's
And
down.
It is down successfully. So
Yeah, we'll have to see if we can get an answer
Yeah.
whether or not it was autonomous.
yeah, we'll see. If it was autonomous, I think that's 150 points. If it was manual, we get 0 points for the landing, but we should still get points for the takeoff, and if maybe we've reported a number in. Okay, if the judge still had, we're just hearing the judge still had the remote, in which case it was probably autonomous.
Now again, those group of judges are tracking that definitively, and that'll be part of the deliberations when they start assigning points at the end of the competition.
Yeah, they won't let me assign the points.
Oh, you've tried?
Yeah.
I mean, I can assign them my own points, but my points don't matter.
Yeah, mine don't seem to matter a whole lot either, so I'll just close my eyes and not watch all the buoys we're hitting.
Now, speaking of things you can assign, for you, is this more of a club, or does Embry-Riddle actually consider this more of a curriculum for the students that are participating?
So we go back and forth on that. So we have a student club we call the Robotics Association, and that actually competes in all of the RoboNation competitions. I believe we're still the only university to do that. So we actually have a total of 7 different teams as part of this club.
Wow.
And then we incorporate one or more of those projects into our capstone design classes as it makes sense. So this year we actually did the Intelligent Ground Vehicle Competition self-drive as part of capstone design, and RoboBoat was an all-volunteer club activity.
Okay.
Next year, it's possible we'll build RoboBoat into the curriculum we have before. And looks like boat's coming back to the dock. It is still in autonomous mode. You can tell by the green light on the tower. If it makes it back to the dock, we'll get a couple hundred extra points.
Yep.
And it looks like it has. At least I would call that a docking.
Yep. All right. I think that's probably about the end of your time slot, too. So everyone give a round of applause for Embry-Riddle.
Yeah, if they still have more time, they might send it back out again, but they probably will not try to fly the quad again. That was a pretty good mission, so
pretty nice quad.
It is. It's about an $800 quad. We'd rather not risk it unnecessarily. So they may just call it a run here. We'll see. It looks like Vincent is fiddling with something there. He may be turning the boat around for another attempt.
Is this a rather young team or a rather veteran team for you guys this year?
This is a pretty young team. We had 7 freshmen out of about 10 people, although one of our freshmen is somewhat unusual. Abigail Butka has actually competed in this as a middle schooler and a high schooler.
Yep, she's a very veteran to this competition.
Yeah, so she's actually our most experienced member, but she's actually in her first year at Embry-Riddle.
Wow.
So
let's see, they're still working on the boat over there, or maybe they are putting the quad back on.
Maybe. So we expect most of our team to be back next year. So I expect us to come back even stronger next year because we'll have a much more experienced team and a boat that pretty much already works.
Yeah, I really like that whole working on the fundamentals of electronics design, power design, mechanical and structural design, and then after that you start building up your software.
Yeah, we went through a lot of iterations to get this right on the mechanical design. They actually built a whole nother boat to test it. They sank it 3 times, but they dug it back up, and they've worked out the bugs. And now our thruster system, other than those servos that we've got to debug a little, has actually mechanically been very reliable out here. I think we've got a really good design at this point.
Yeah, you reminded me earlier in the week, someone made a comment that looked like your boat may have been listing, and they were worried about maybe it was taking on water, and your response was?
Yeah, they know what it looks like when it takes on water. Yep. Because it won't actually sink to the bottom. It has enough built-in flotation. You can't physically sink it. It will, if the thrusters were to leak, it would flood. But that's what they spent all the time this year figuring out, was how to seal that properly while still letting it rotate, which is a complex mechanical problem, and I think my team did an excellent job on sorting that out.
All right. Well, it looks like your time slot is over. The judges are switching out, so I thank you for talking to us. And we are going to take a moment to get ready for the next team.
All right. Thank you, Bill, and we'll see how the judges score it.
All right. Good luck. All right, we're actually back for a few moments. I'm here with Greg Bartholomew, Parks and Recreation Director. So Greg, this venue we found, we used to be based in Virginia Beach, and now we're down here in Daytona, and this venue is just gorgeous. This has been an amazing opportunity for the competition to grow down here, and you guys have just been overwhelmingly supportive of hosting us down here. Why does Daytona think this is an important competition to host?
Well, we're glad to have you, first of all. 3 years ago, RoboNation, AVSI Foundation at that time, was the official name, contacted us about coming here. I believe Embry-Riddle had a hand in that. They practiced their boat here for your competitions every year, so they would come out and they would use our lake. And but we're glad to have a high-level activity that's going on in the community that really showcases technology and what the future holds for humankind, actually, and what you're trying to accomplish. So it's a great opportunity for people in our community to understand what technology is doing and how it's advancing, and it's just a wonderful experience for people to be able to come and see it. It's nothing like anything that ever happens here. So it's totally different than what you would normally see in the Daytona Beach area, and we're just proud to be the host city.
And to be clear, the host city is being South Daytona.
That's correct. The city
So
of
we're-
South Daytona.
so
We're not
we're-
Daytona Beach. Everybody thinks we're Daytona Beach. We have no beach. We're just a small 3.5 square mile city that's sandwiched between Daytona Beach and Port Orange. And we have a lovely lake that's been used by our model sailing club for years. And it offers a really unique opportunity. And it's got great visibility to one of our major highways that runs up and down the county.
Yeah, we really appreciate it. This venue has been just stellar. It's given us an opportunity to really think about how we can grow this competition, and this site gives us so much room to grow. So it gives us a lot of excitement to be here, and thanks again for having us.
Oh, you're welcome.
Is there anything else you want to say about South Daytona or the community?
Well,
or?
yeah. We South Daytona is a great little community. We have a very supportive council. Our city council gives us the opportunity to do what we need to do. They're excited to have this competition here. We love to be a part of the community. We love to provide for the community, and we couldn't do it without their support. And we love working with RoboNation. It's one of the most amazing groups I've ever worked with. You guys come in, you do everything. You come in with massive amounts of staff, and things are done well, they're done right. And it's just been a great partnership. And it's also allowed us to create another event that goes along with this event that we did yesterday, the Technology Under the Big Top event that we did. And we had some activities for kids with some STEM projects and that sort of thing. And then we also had some non-technological stuff. We had a blow-up water slide because, as you know, it's 95 degrees in Florida in the middle of June.
Yeah, I was very sad I missed the slide, and I wanted to go down that.
So we had a really successful event yesterday with a couple hundred kids that came out and families, and that's what it's all about, to introduce kids to something new that they might not be getting through their normal daily activities. So we're glad to have it here, and we're glad to be a part of it, and we're going to continue to help make it grow.
Oh, yeah.
And
for those that missed that event yesterday, we will be back next year, and
Yes.
we'll likely have a similar event.
Absolutely, we will be, and hopefully even bigger and better. And I appreciate those that came out. Again, just to give a shout out to Amy Monahan with Volusia County Schools. She's our STEM coordinator. She
Ooh,
brought
yeah.
out about 10 activities for kids, and then we had the Volusia County Bomb Squad with their robots that were out here, that they're bomb detonating robots, which was really interesting. A lot of the students, even the participants in your competition, were really interested in what they were doing over there. And Embry-Riddle brought out some virtual reality stations and a 3D printer, and so we had a lot of good stuff out here going on. So it was really, really a wonderful day. But again, Bill, we appreciate RoboNation and the Department of Naval Research trusting in us and bringing this event here, and we're glad to host you every year.
Thank you, Greg. All right, we're going to take another break while we get ready for the next team to enter the water.
ITS Road to International RoboBoat Competition 2019. This is Sunday morning. Galaxy 4 is ready to launch in 5, 4, 3, 2, 1.
We are RoboNation, a team that focuses on conducting research in the field of maritime affairs. Yep, we made an autonomous surface vehicle, and this June we plan to return to the 2019 International RoboBoat Competition in South Daytona, Florida, USA. So first, electroprogramming division. They are responsible for determining the electronic components used on the vehicle and for making algorithms like object detection that allow the vehicle to pass the obstacles given during the competition. So they are actually the brain. Next, mechanical division. All needs related to vehicle design, construction, and outfitting are the responsibility of this division. Shout out to Andre and Alan. Of official division. Their role in this team is also critical. They have to ensure the non-technical stuff like administration, sponsorship, and branding run normally. Last but not least, this is our captain, Stephen Karamar. As a captain, he makes sure everybody in our boat is rowing and not drilling holes during the voyage. Individually, we are one drop, together, we are an ocean. We know Gusti Pangeran Boten Sari. We will rise and stand tall to become the champion.
All right, we are back here at RoboBoat in South Daytona, Florida. I'm here with a representative for the Institute Technology, Sepuluh November. Can you introduce yourself?
So yeah, I am Sabila. I am here as the leader of official divisions in my team. And yes, that's
Okay. So where are you from?
So I am from, me and team are from Indonesia. We are basically from Surabaya City at the very east coast of the Java Island. So yeah, a lot
Okay.
of Indonesian team in this year, as you know, but we are actually from the different state,
Okay.
let's say.
Well, we started with the team that has the smallest commute because they just drive down the street from where they're homing, and now we have the team that probably took a lot longer to get here. About how long did it take to come here?
22 hours for the flight.
22 hours of flights?
And
Wow.
for the around 15 hours for the transit. So that's basically 2 days.
Wow.
But we have moved backward for like 12 hours in here because of the different time zone. So
Okay.
it is just counted as like 1 day because we have our departure at 10 of June and we have arrived here at the 11th of June. But it's
Okay.
actually more than 24 hours.
So that's actually a whole new challenge to this competition because you have to get your boat and all your robot and all the parts here. So
Uh-huh.
what kind of challenges did you face getting that stuff over here?
Yeah, actually this year we got a little bit problem because of, as the last year, we separate our boat as the 3 parts. So the boat can get into the baggage. Actually, the last year boat is bigger than now, but now we design it a little bit smaller, and we did it, and we don't separate it. So all of the boat only got into the at the big box, and I've got a little bit problem due to the island because not all of the island can accept that big box. So I have
okay.
choose the right one, and yeah, so we got the Lufthansa at like several weeks before our departure, so that is why.
Okay. Does the fact that you have to ship the boat, you kind of said it goes into 3 parts, so you actually designed things about your boat to make it easier to ship. So that was actually another aspect of the competition that you had to think about as you designed your boat, correct?
Yes.
Okay. How many team members do you have here?
7 members in here, and we've got 2 advisors.
Okay. And your advisors came with you, or is it just the team members?
Came with us.
They came with you? Okay.
So yeah, we are 9.
Okay. So what do you hope to do in your finals run?
Actually, we can complete all of the missions.
You can complete all of them.
Yes, that
Oh,
is what we
man.
hope.
You guys were, when the teams get to pick the time slots for the finals, and you guys scored pretty high, so you actually got to pick first. And usually they always pick the last slot, but you guys were like, no, we're confident. We're getting
Yeah.
that early time slot. So this is the team to beat right here. Oh, it looks like you're already underway too. So is the idea? I actually see a quadcopter on there as well. So do you plan to fly the quadcopter?
Depends on the condition because we will do several retry in here. Of course, we will do like 2 times at least, and we will see the condition about the wind and stuff.
Okay. Oh. And it looks like it's coming up to the speed gates right now. It does not take any time to think about it. It just goes. Are you always going to start with the speed gates and then move on?
Yes, basically.
Okay. So it's coming around that blue buoy. Oop. Oh, wow.
Because this is the easiest one and this is the closest one through the dock. So
Okay.
it's better for us to start it first because it is also takes several times, at least several seconds to get through the find the path and some of the missions. So that's why we start it first.
That is a very decisive robot. So what kind of sensors do you have on the robot?
The sensors, so what? Actually, we only use the proximity sensors, the SRF. That is, we put it 4 in front of the boat.
Okay.
And so we also have another sensor, the light sensor we call it. We put it on the left side of the boat.
Okay.
And
So you're using proximity sensors to see the obstacles, and then you're using a light sensor to determine their color?
yes.
Okay.
And we mostly play on the cameras, the computer vision rather than the others.
Okay.
And also the hydrophone, of course, for the automated docking mission.
Okay. So it looks like it's looking for a way in through the buoys, and it's decided it's found one. So the task here for the audience is that it needs to find its way through that obstacle course and circle that buoy in the middle. Looks like it might have touched an obstacle there. And it definitely sees the buoy, so we got hopefully it's going to circle it. Now you said you're the team lead?
Sorry.
You're the team leader of your team?
No, I'm the leader of the official division because my team is basically has 3 divisions.
Okay.
That are electrical, mechanical, and official. So I'm the leader of the official division itself.
Oh, okay. So it seems it's circled the buoy and it's trying to find its way out now. I think I hear some beeping coming from the boat. You know what's the beeping noise mean
The beeping noise.
on the boat? It sounds like maybe it's the quadcopter.
The beeping sound.
Yeah.
For now, there's no beeping sound, I guess.
Okay. So now it looks like it's found its way out of the obstacles. What task is it going to go to next? Oh, it looks like it's going to find the number dock, maybe. So again, for those spectators watching, this is an autonomous boat competition. That boat is driving itself. There are no humans involved with the operation of this boat right now. So we are looking to see how it performs using its own sensors and computational power on the boat. So we had one question. The question was, on the front of your boat there, you've got something that looks like it's a piece of plastic and a metal grate maybe. What is that for?
Yeah, that's actually just we just arranged it like 2 days ago, because actually when we did the trial at the very first time, we found that our boat cannot push the button on the raise the flag mission. So it's not that tall and it's not that long, so that is why.
Ooh, and we got the quad launching.
Yeah.
So I'm sorry to interrupt you, but so that's to push the button?
No problem. Yes, that is for pushing the button, of course.
Ooh, that is a fast quad. They might have taken over manual control when they saw how fast it was moving. Is it attempting to land? Are you just going to try to land it?
I think so.
And it does look like it's trying to land.
It's gonna land on the dock.
Wow.
Okay, it went smooth.
Okay.
Because actually when we try our very first launch, our drone get crashed and get floating into the water. And after that we just bought all of the components and we just arranged it from the very start.
And that was this year?
Yes, and
So this
now
is a whole new
it
drone.
works. Not a whole new. We still have the same frame,
Okay.
but all of the components.
All the electronics,
Most
the
of them are
motors. Okay, wow. That's impressive. You were able to build a whole new drone in the course of this competition.
Yeah.
All right, looks like they're going to reset the drone on the boat and go again. again, this competition is best run, so there's no reason why you shouldn't try to use up all your time and see if you can get another run out of it.
Yes, that is also good for us.
Now, are you always going to try to run the same mission, or are you going to change which things you do each run?
Yes, probably we will change it still because of the sunlight can get some noise on our camera also, so that is why we put it depends on the situation.
All right, looks like it's underway again. Ooh, going right for the speed gates. So is that the max speed for your boat? Does it go any faster than that?
I don't think so because the trim is not as high as I ever seen. Because
Okay.
when it gets so fast, the boat will get trim really, really high.
That looks like it got a little confused.
Uh-huh.
People tend to think that, you know, of autonomous robots, the buzzwords right now are autonomous cars. And in cars, you got nice painted lanes. But when you're a boat out here, there's no lanes to look at to try to keep you in a certain area. So you gotta kind of work off trust. And then when you see an object in your sensor data, make a decision what to do about it. So that time it looked like it didn't see the buoy until it was too late and tried to turn and just didn't have time. Would you agree? Oh, it's going again. Let's see if we can go around the buoy this time.
Yes, they started from the very beginning because they get the obstacle.
Ooh, nice turn. So how often do you work on this project back home? Is this a class for you, or is it a club at the university?
No.
No?
We left a lot of class for this actually.
Oh, really?
Yes, and we were from until the night, like have a sleepless night and stuff for this. So yeah,
Oh,
we
man.
made it for only 6 months.
So you had to take all your regular classes plus spend time doing this.
Yes.
Wow. Is this the only robotics competition you do?
No, we also have the national competition which held by our Ministry of Research and Technology.
Okay, so it's more local.
Yes,
Yeah.
and for the international, so far is only this one, but we are planning to join the another one, but we are still now doing our research because the different specification and stuff.
That's okay, because RoboBoat's still your favorite competition, right?
So far, yes.
Yeah. It is definitely taking a tight turn around that buoy in the middle. Are you going to attempt the docking task at all?
Yes, I think so, because we did it several times on our trial.
Okay. Now, we've already seen that it looks like you have a lot of fans online. Is there more team members that couldn't make it?
I'm not sure who are they.
You know who they are?
Some of them, yes, I know, but the others are not. But yeah, we are reaching our followers also on the social media because of we do know that all of our social media is also counted as the static judging point, right? So that's why we are active on all of our social media.
All right. Have you been able to find sponsors to that as well? So sponsors are like companies that give you money or parts?
Yes, definitely. We've got a lot. Fortunately, this year we've got a lot of sponsors, for like 20 companies.
Oh, wow. Okay. Now we've seen the quad take off. It looks like it's actually going to observe the 7-segment display. Once again, there is a screen on that dock right underneath the quad facing up. So that challenge requires the quad to have a camera facing down to observe that screen, relay it back to the boat, and the boat will make a decision based on the observation. So let's see, the boat's kind of loitering around waiting for an answer. The quad still looks like it's looking for the number. Now, will your boat stay here until it gets an answer, or will it go on to do another task?
The boat is trying to turning around, trying to classify the number.
Okay.
Which number that the drone got, yes.
So it's actually looking at the dock right now to figure out which number is on which side.
Because actually now the boat is thinking, the brain is working so damn hard.
You can see the gears turning, thinking. All right. This again for those watching. This is no humans involved. This is a boat driving itself and a quadcopter flying on its own, working together to solve a problem.
Yes,
And that problem is which button to push.
Yes, and the camera is turning to the position where the number on the dock is.
Okay.
So that it's our camera is not the static one. It can turning around to the left and the right.
Up, and it
And
looks
it
like
started
we
to
can't see from this angle with the flag raised, but we'll have to see if the judges are going to call that a successful raise the flag. For those watching, when you press that button, a little flag comes up to show that the button's correctly actuated. All right, the quad is now coming back to the dock, it appears to be. I think this is going to be the run to beat right here. Yeah, the quad's getting closer to the dock, and the boat seems to be going to the docking task and striking the docking task. So that's the point of that task right there, is to find the correct bay. The correct bay is designated by an underwater acoustic beacon. So the boat has to have sensors to sense the underwater acoustic beacon and dock in that task. And I think the boat has decided it has finished that task. And the quadcopter has landed on the dock. Is the boat programmed to go back to the dock when it's done?
Yes, we usually do that.
All right. And for those watching, if the boat returns back to the dock, it is a bonus points multiplier for all the tasks that they've completed. So it's worth the big points. All right. It seems to be lining up at the dock. Wow. And it's back to the dock. All right, that was a good run. So you were telling me a couple minutes ago before we started that the name of your university actually has a meaning. What's the meaning to the name of your university?
So the 10 November itself is actually a date at the 10th of the November, the day where there was how I can say it, the young man in my city in Surabaya got not the independence, but yes, probably that's an independence from the Netherlands, because my country is under the colony of Netherlands, like at 1940 something.
Okay.
So yes, that is the day when we got the title of heroes in my city. So Surabaya is basically the city of heroes, and also the ITS itself named the campus as the campus of heroes.
Wow.
So that is why.
That is very cool.
Yes, this is the old one and the public university.
Wow, you guys are going again and going really fast.
Yes, because we are always trying to get our very, very best score.
Oh wow, that is a good mentality to have.
Yes.
And it is around the first blue buoy like it was nothing, and going back to the gate.
We'll never feel enough as long as there is still a spare time for us to try.
Okay. And we are through the gates. How does the boat decide when to launch the quadcopter? How does the boat decide when to launch the quadcopter?
I'm not very sure about it, but yes, the programmer one that over there have the I don't know how he maintain it, but yes, there's after the find the path, because we're doing speed challenge first, and after that the find the path, and after that the drone will launch, and we'll start to read the 7 segment, and the boat will classify the number.
Okay, so it always launches after find the path.
Yes.
Okay.
So there's no specific time or the specific qualification for that.
Okay. It does appear to have made it through the obstacles and is now circling the buoy in the middle. And again, I can't stress how amazing it is to see this kind of behavior. And remember, this is not a human driving this. You know, some people in passing may say, oh, I can drive a boat and do that. But this boat is not being driven. It is all on board. There is computer and software running that is controlling that boat.
It also can be seen at the mushroom lamp that we have at the very top of the boat. As long as the indicator says it is green, so that's fully autonomous.
Okay, so that's what that light on the boat means. When it's green, it's autonomous.
Yes. And for the tower lamp itself, we made it ourselves actually. So, and they called it a mushroom lamp
A mushroom lamp?
because of its shape.
Oh, I see. Julianne, who am I interviewing next? Oh, and here's a quad. Ooh, that is a good takeoff. So now the two different robots are going to work together to solve one task. The quadcopter is looking down to observe the number on the screen, relaying it to the boat, and the boat is going to press the button under the corresponding number. That is, if everything works well. Did you guys do a lot of practice of this one back at home?
Yes, sure we do.
Okay. What has been the most fun part for you in this competition?
I don't know, probably the tenses, because of at the very beginning of this trial, we did not launch our drone at all. Meanwhile, a lot of team over there launched their drone, and we're like, okay, we should launch our drone.
Ah,
And yes,
competition.
that kind of tense. And we did a lot of trial on the field. And when we did a trial with the boat, also our blade of the drone get crashed with our boat itself. So
Uh-oh.
yes, that is why we're still considering whether should we launch or not. That kind of tense that which make this competition fun, I think.
Okay, you like the challenge.
Yeah, some kind.
Sometimes. All right, looks like the quad thinks it's done its job. Let's see what the boat does. It looks like it's stalking the dock. So while the boat is circling the dock like that, it's observing every number to remember where that number is. That's what it's doing?
Yes, because of the programmer man over there, Rashid, we can call his name, using the deep learning for the classification of the number. We
Okay.
tried so many times for the data set.
Quadcopter is coming in for landing, and it looks like it's going to make a landing on the dock. Yep, there's the quadcopter landing on the dock. All right. Now the boat is making it away to the docking task. Again, that docking task, the boat has to decide which dock to dock in based on an underwater acoustic beacon. We don't know which one's on right now, but we can see what the boat is about to do. And it looks like it just went for the number 1. And it seems to be happy with that decision. It's now coming back. All right. Well, maybe it's not happy. Maybe it wants to take another try at it. Going for
Probably the
number 1
boat
again.
did not consider the first one as the docking because of it get crashed due to the foam, and the boat do the try the dock again.
So it's decided that it hasn't finished that task yet, so it's going to try it again. Oh, that looks like it might think it's done now, though. Do you have any code that has a timeout to try another task if it takes too long to finish that one?
I'm not so sure about that, but we have our captain over there. Show him Steven, who is the one who do the manually.
Okay. All right, it looks like it's still in autonomous mode, and it seems to be coming back to the dock. Let's see if you can get those bonus points for attempting all the tasks and coming back to the dock. All right, it's coming to the dock right now. Hopefully it slows down a little bit, and it's docked. Wow, another impressive run. You guys have really nailed this, haven't you?
Thank you very much.
All right. Looks like the judges are coming back in, so I think
Yes,
that's
I
the
think
end
that's
of
the
your
last
run.
one.
Well, thank you for talking with me.
Yes, thank you, Will.
We're going to take a moment to pause as we get ready for our next interview.
Hold the mic? Yeah.
All right, we are back in South Daytona. I am sitting here with Kelly Cooper.
Hey, Bill.
Hi. So you were the person that actually has helped make this competition come into existence. So can you explain who you work for and what you do to make this competition exist?
So I am a program officer, and I work for the U.S. Navy. And a well-performing team just went behind us, and they're congratulating and wishing the next group luck. So a lot of camaraderie here. I work for the U.S. Navy, and I work at the Office of Naval Research. And so we're responsible for managing a portfolio of basic research. So as such, we're concerned not only about the technology, but the infrastructure to develop new technology, to work for the Navy labs, for the Defense labs, for the Department of Energy labs. We're also concerned about people entering emerging fields of technology, and also making sure that there is a solid base of researchers in academia conversant with emerging technology so that they are educating the next generation.
Okay.
So that's what we do.
So I've heard training the workforce a lot. You know, we're trying to, you know, we heard an earlier team talk about how you can learn theory in a lab, but it's meaningless until you actually learn how to get some experience applying it. And this is the kind of event that gives them that experience?
It really is, because you know, there's an element of senior design, which is supposed to be an accumulation of all of the engineering knowledge and all the coursework they've done up to that point. A lot of universities have a hands-on build something project, but a lot of them have really a paper project. This is very much hands-on.
Yep.
But at the end of the school year, there's often not a lot of time to really test what they've built. And this really tests what they built. And it gives them a chance to pull it all together, to prove it works, and to continue to learn. They learn through failure. If everything worked perfectly, then, you know, this wouldn't be hard. The fact that it doesn't work perfectly forces them to interact with other teams that have something working well, to share knowledge, to share best practices, and we see them do that again and again. They learn from each other, they learn from the course, they pull all of that in practical knowledge into their education.
Yeah, I think we saw an example of that. Georgia Tech had an issue where their Wi-Fi was malfunctioning, and ended up being their Velodyne was sending too much data through their network. So one of the other teams had to help them set up their Velodyne correctly to not have that problem.
That's easy for you to say.
So it's great to have these teams all in a big tent. That you see a lot of, like you said, camaraderie of the teams talking back and forth.
I do want to go back to what your first statement. You do me too much credit. There were some early pioneers in developing these sorts of competition for maritime autonomy, who were other fellow program officers at ONR. Tom Curtin, Tom Sween, and others. And they invited me to be a judge at one of their events. And I was struck by the fact that there were whole teams of computer scientists and electrical engineers, none of whom were mechanical engineers, maybe occasionally, but no naval architects. And they could put enough power in the water and with the right sensors run it for 15 minutes without understanding Bernoulli's principle, Archimedes. And I suggested to Daryl that the surface was, you know, more challenging than underwater. Sure, underwater you got to make sure everything stays dry.
Yeah.
And that's a challenge for electronics. You also don't have GPS underwater. However, at the surface, you have so much more interference with sunlight and, you know, the water surface. So it's the air surface and the underwater interplay, I think, that makes
This challenging.
RoboBoat incredibly challenging.
Okay.
And adding the element of the air vehicle with it.
Yeah, that is very cool.
Yeah.
And
And
fun to-
cooperative behavior.
Multi-domain. I do want to ask you one more question before we move on to the next team, and that's about the judges.
Okay.
I figured you'd be the best person to kind of explain who our judges are.
So we have judges that from all walks of life. Many of them are subject matter experts in a particular area of science or technology that's applicable to this. Many of them, some of them are retired from government service or from a profession as a researcher, and many of them are new, coming into the field. We have judges this year who competed when they were at an undergrad and master's level.
Wow.
Back in the day when RoboBoat was in Virginia Beach. And now they are working for the Navy, and they are active judges out here on the course. They give us a good perspective of what the students go through and what the students are looking for and what makes the experience the best experience for the students.
Okay. Now it looks like our technical director has actually entered the course, so I think we may be correcting something that may have been hit a little too hard in the last round.
Yeah, they're straightening out the lanes for the docking task.
Yeah, okay.
Great. Yeah.
Let's see. Anything else you'd like to say before we get ready for the next team?
No, I really appreciate the opportunity to speak. I am so grateful for RoboNation and for Reed Canal Park. The Parks and Rec service here has just been amazing. They let us come back year after year. They do all they can to support us. And we want to grow the competition to 30 teams next year. And we've got plenty of real estate to do that out on this lake.
Yes, this venue is absolutely amazing.
Yeah, it's fabulous. Yeah, and they are. Just working with these people is great.
Oh, yeah.
So, thank you all.
All right, and that was Kelly Cooper, and we're going to take a pause as we prepare for the next team to enter the water. Hello again from South Daytona. We are preparing for our next team to start their run in a moment. That is Vantec. We're still waiting on their team captain to come over to interview, but it appears they are at the dock and preparing some things in their boat, so we're hoping to see some excitement soon. So those watching, this is one of the challenges of robotics, is sometimes things just don't work when they should. It looks like Vantec's still working on something in the dock here. As soon as we find out anything, we'll let you know. Good news, it looks like we have some movement from the dock. I see the boat starting to make its way away from there. Hopefully we can get their team member over here soon to start telling us what's going on. We just got word from the judges they have been on the clock. They only have 10 minutes left in their run. It looks like they're still working on debugging some gremlins from their robot. Let's hope they can find that bug and get underway here shortly. All right, we are still here live from the 2019 RoboNation RoboBoat Competition. Vantec currently has the water, but they are still working on some issues with their boat. So I believe they have some time left, but we're hoping they can squash whatever bug is keeping them keeping them from leaving the dock. And as soon as we see something, we'll let you know. But stay here with us to see the finals for the 2019 RoboBoat Competition. Oh, it looks like Vantec is pulled away from the dock. We're going to see something exciting, hopefully. I see the quad has been installed in their boat, and it's coming up to the speed gates. Once again, you're watching the 2019 RoboBoat Autonomous Vehicle Competition. No one is driving that boat. It is driving itself. Ooh, and I hear the quad. There goes the quad taking off from the boat right now. All right, some excitement from the crowd. That quad is going right over to that task. So once again, there is an element to that task underneath the quadcopter where there's a screen that only faces upward, meaning you have to have an aerial vehicle to observe it. So the quad seems to be performing a maneuver to find that screen. Judging from watching the quad, it's a behavior called mow the lawn, or because it performs parallel tracks to try to find the area where that screen can reside, much like the tracks that someone follows when mowing the lawn. Ooh, it's getting close. Let's see if it can find it. The boat seems to be keeping station, waiting for an answer. And I'm still hoping I can get someone from Vantec to come over here and talk to me.
So what should I say?
All right, so I am here with a teammate from the Tecnológico de Monterrey. Can you please introduce yourself?
Hi, I'm Alex from Vantec, from Mexico.
Okay, wow. So you guys had a bit of a travel to get here too then, huh?
Yeah, we had a lot of trouble, just 2 days of a trip from back home. And right now we had communication issues, so our radio is not working.
Your radio's not working. Okay, so
Yeah.
how'd you resolve it?
We didn't.
You didn't? Uh-oh.
No. We just let it go and try to see if anything does. If anything goes, pass to the speed gate, and the drone launched. So
All right, and it seems to be going back to the dock. Do you plan to land the drone autonomously on the dock?
we were, but the DJI is a little bit sensitive, so it does not let us at the moment.
Okay.
Yeah.
All right, the drone has landed. All right. So once that happens, is the boat going to do anything?
No, it's in manual, so I think our round is over.
Okay. So what kind of what this competition? Why do you is this part of your curriculum? Is this a club at your school? Is this something?
We started a student group. We were really eager to try and do something else. 2 years ago, in 2017, a guy wanted to see if he could do something else. He asked a friend around. I got involved since the first year of we were together, and then we just came here and did something. We launched a drone.
Yeah, you did.
Yeah,
Very
that was
impressive.
2 years ago, and then everybody graduated except for my friend and me. So
All right, so you're a veteran on the team.
yeah, I'm a veteran. I'm just a fourth year, so
Okay, wow.
yeah, I'll be a fifth next year.
So you plan to come back?
Yeah, I plan to come back.
All right.
This is my third. It will be my fourth, and we just started to keep it from the ground up again. Then again, most of the team that came here went away, and most of the guys are new.
Yeah.
So
It makes you really have to focus on documenting lessons learned and kind of
Yes.
making sure that technology can move from one student to another, correct?
yeah, we did a lot, especially in the computer vision part. And right now, for example, the communication is the same one as last year, and last year was working. Actually, yesterday was working well. So today we don't know exactly what happened.
Okay.
To find the path was working sort of well. At least we got to deploy the UAV, but we were really eager to try to do something really great this year. We're feeling bad at the moment.
Yeah.
Yeah.
Well, you guys should still feel great that you've learned a lot, right? You come
Yes.
here, you interact with other teams.
We love that part, and I really appreciate how most of the teams really see us and try to come with us. And one of them say that we are the chillest guys here, and we really enjoy that title because we love to make friends, and we love to be nice, and we love to be helped, and we love to help. And well, this may have not been what we expected as soon as we got in the finals, but getting back to the past years, this is actually a huge step for us. For the past 2 years, we didn't even get to the finals. Right
Okay,
now,
wow.
we're in the top 5.
That's the right mentality to have.
Yes.
Now, I have to say, I did see that there was another competition going on these past couple days. There might have been some soccer games going on in the field over there.
Probably, but we don't know anything about it.
Oh,
No, we don't.
so what's the score for those games?
It was 4-0.
4-0.
But we love them. It was a really nice game to play. We love you guys.
Well, very cool. And it looks like the judges have come back, so I think that's the end of your round. And I'm really glad you guys are happy with your performance, and you've had a good time with being here. And it was good talking to you. Thank you, Alex.
Good. Just to clarify, we're not exactly happy. We're satisfied because we did something better than we did before.
Okay.
But we're not happy because we were really eager to try and go for the second place. Right at the
You
moment.
guys, don't be too hard on yourselves. You guys accomplished a lot.
Yeah, we do.
All right. Thank you, Alex.
Thanks, Bill.
All right, we are back at the 2019 RoboBoat competition, and I'm sitting with Felix Pajot, the technical director. How you doing, Felix?
Hey, pretty good. How you doing, Bill?
Oh, I'm a little hot. Other than
Yeah.
that, I'm doing pretty good. This has been fun to watch. We've seen some excitement already.
Oh, it's been really fantastic. We've had a great final so far, and we've got 2 more teams coming.
We do. So, as technical director, a lot of these elements of these tasks are things that you designed. You know, what are we looking for with these different tasks that we build? What are we expecting to see the behavior from the robots?
Well, the first thing we're trying to see in all of those courses is autonomy. So we're trying to have the boats actually make decisions for themselves based on sensors and react to the environment that they're in. So if we look at the different obstacles we have, the first one is our speed challenge. We want boats that have a great naval architecture so that they can quickly move through the water, they can navigate a turn and come back. So this is all about like ship design and having an efficient boat.
Okay. And how about like the multi-domain stuff? What are we trying to see with this multi-domain task?
Multi-domain is really fun. So we're trying to see that the unmanned, the autonomous vehicle is not just a single boat, but is actually a collection of different vehicles that are each moving and making their own decision, but also collaborating together. And that's one of the big things about like unmanned vehicle is once you're able to get that collaboration, you can go multi-domain. You can go below the water, above the water, you can go on the ground. And the great thing about those surface maritime system is that they're kind of the link between all of those systems.
Okay. Now you're actually you graduated from one of these competitions, correct?
I did.
Oh, so you were excited to continue to see this competition like this grow.
Definitely. A long time ago, I used to compete in the submarine competition.
Okay.
RoboSub was actually coming in a few weeks in San Diego. So I encourage everyone who's watching this podcast to also dial in when we're going to be doing RoboSub as well. That should be another great event. And you know, those competitions are really interesting because they help students take some of the, let's call that like theoretical knowledge that they've learned in classes and apply it into something concrete, something real, and really kind of like turn that like knowledge into a skill.
Okay.
And that's really what we're trying to do here.
I had Embry-Riddle give me a new quote that I really like, and it was that software can win this competition, but hardware will lose it for you.
That is spot on. I love that quote.
Yeah, I thought you'd enjoy that one.
Oh, yeah.
And that just talks about some of the engineering fundamentals that teams really need to make sure they have a solid foundation for before they jump into too complex of software problem.
Yeah.
And does that kind of drive some of these challenges out here where we want to make some that might be a little bit easier versus some a little bit harder?
Definitely. I mean, some team would be able to do just about every one of those challenges with just a camera and a compass. And they would be able to actually compete and actually do some part of most of those challenges, which is really the great thing. And other teams are going, you know, like full complexity. They're starting to put, They have drones, they have GPS system, they have lidars. Some of them have like additional like ultrasonic sensors and things like that. So you can go really complex or really simple. And the thing we really like to see is when a team is able to take a very simple set of sensors, a very simple like approach to things, and are able to get like very complex result out of it. We love to see that type of innovation.
All right, we actually starting to get some rain in Florida, something that we expected but haven't seen the past couple days. We've been kind of lucky. So I think we're going to see a little activity as people get ready for the rain, but I don't think this will stop the competition yet because these are boats, right?
I know, and we keep reminding everyone RoboBoat is a rain or shine event. Today it looks like we're getting some rain. As long as we don't get any thunderstorm over here, we're just going to keep on running.
All right. Can you tell us about how the week's gone and what we've seen at this venue and some of the teams perform?
The week has been really interesting. It started quite slow. Most of the team were actually doing mostly remote control operation, so we didn't have much autonomy actually being demonstrated until about Thursday or Friday, and it really ramped up quickly after that. So I think that a lot of the team needed to like just test their mechanical platform, make sure that they were able to go in a straight line. They had like battery system they could swap and things like that. So we've seen a lot of like base things being set up in the first few days, but for the past 2 days or so, it's been fantastic. We see teams that we had actually a great story. The students from University of Colorado at Boulder. Yesterday morning, they did not have thrusters. They had a bunch of components that were not installed. And by the end of the day, they were able to go in the water, go in straight line, pass the autonomous navigation, and even hit some of the other obstacles after that. And
Wow.
that was all in the span of 1 day. So sometimes we see like fantastic progress in a short amount of time.
Yeah, and I think a lot of having a big tent with all the teams in it where they can share knowledge and work together to solve problems. I think that we see that fosters reactions like that sometimes.
That's definitely been great. We've seen the students actually exchange tools. Some are even borrowing component. I've heard something that in the next few final we might see a team that has borrowed a drone from another team.
Ooh.
I know, that might be really interesting to see.
All right. Well, thank you, Felix. Is there anything else you'd like to say before we get ready for the next team?
No, we're really excited to see all the teams today. We're having a great final so far, and really excited to see what's going to be the outcome of RoboBoat 2019.
All right. Thank you, Felix.
Assalamualaikum warahmatullahi wabarakatuh. Good day, everybody. My name is Alifika Fikri. I am as the leader of Autonomous Marine Vehicle Universitas Indonesia. IMVUI is a place for 25 members that come from many majors in our university, like electrical engineering, marine engineering, naval architectures, mechanical engineers, computer science, and others. IMVUI currently developing our latest product that called Makara 09. That
Let's try again.
Yeah, let's go for again.
So how many time we have?
Oh, I actually don't know. That's
okay.
the judges are the ones that track the time.
Okay.
So what was more challenging about this competition this year?
The most challenging is about this different place when we have try.
Okay.
So we have to try as many as possible and try something the data and also another trials.
Looks like your teammates are working on the boat a little bit there and get ready for another run. So did you guys have a good area to test your boat when you were working on it back home? Did you have a good area to test your boat?
Yeah, we have tested our homes that it's properly working, but it seems that the router is lost. We have a good routers that place in the back we have lost, and we have changed the router that it's more cheaper than our routers before,
Okay.
and it makes some problem.
Okay.
when
So
we
what you're talking about is the Wi-Fi radio on your
Yeah.
boat that communicates back to your
Yeah.
base station.
yeah
And you had some difficult since you lost yours. You've
Yeah.
had some difficulty using the one that you could find here.
that's what I mean.
Okay. Can you tell me a little bit about your thrusters that are on the boat?
So we have used Blue Thruster T200, and we have used two propellers that back to the hull, and it's used azimuth thrusters that we can pivot in the water on the water.
Okay. Well, it made it to the speed gate. It went around the blue buoy and gave it a nice safe margin. It looks like it's going through the speed gate again. So after that, you're going to go try another challenge. All right, get some applause from the audience there.
Thank you, guys.
All right, now it's making its way towards the 7-segment task with the raise the flag.
Oh my God.
Ooh, it's going to make its way towards the docking task. Now, do you actually have any hydrophones in the water?
Yeah, we have had an hydrophone in the bottom of our boat.
Okay.
Oh my God. Okay.
That was that looked like it didn't even want to stop. It was just coming to say hi, and then it was ready to go to the next task.
Yeah. Because we don't have the button push for automated docking.
Now it's made looks like it made a nice clean cut right into the obstacles there. It's found the buoy and it's thinking about circling. Uh-oh, might have been confused by that orange buoy.
No. Ah.
Oh, looks like it's hit that buoy right there.
Oh.
And once again, this is an autonomous robot challenge
Yeah.
competition. So we have to teach that robot to differentiate which colors are out there and what to do when it gets near one of those colors. So it looks like you're back in manual and you're going back to the dock
We
now.
are going back to manual.
All right, you're back at the dock and turning around. Looks like you guys are going to get ready to go again. Do you guys find that you have a lot of energy in your batteries to do a lot of testing?
Yeah, actually we have 40 minutes to operate.
40 minutes of battery power?
Yeah,
Okay.
battery power.
Plenty of time, right?
Yeah, plenty time.
Now, is this a? Do you guys practice for this competition all year, or?
This is the last years we have not joined this competition,
Okay.
and this is our first.
Is your
And
first year?
myself is this for my first time come here to join this competition.
Okay. And how long have you guys been practicing with your boat?
Actually, we have used this boat when in the national competition,
Okay.
and we have used this same boat. It almost 6 months ago.
6 months ago.
Yeah.
Okay.
It is just for the boat, but the system inside the boat is maybe just 1 month, because we have joined another competition that we have to focus and separate the focus.
Okay. Do you guys form different teams in your team? Like, do you have electrical team and a software team?
Yeah, we have spread 3 division, that mechanical, electrical, and AI.
Okay.
And responsible to you know the name.
Well, it looks like you guys are going for another run.
What?
Oop. Maybe it's getting a little too attached to the dock there.
Makasih banyak Om.
All right, you guys are underway again, looking for those speed gates. Looks like it sees that green buoy and it's going to use it to navigate around, or maybe just a little bit. That was pretty close. Now, I know we are a little hot, but have you had issues with heat in the robot itself? How do you cool the electronics on the inside?
Yeah, it is maybe the hardest problem that we have faced in the trial section, that our some electrical system are not working because so many heat, and we have used the foil upside of the boat. You see?
I thought that was for fashion.
Yeah.
You're saying that actually has a practical use?
Yeah, it will prevent the heat, and also we use a fan.
Okay. So that tin foil on the top is to reflect the sunlight so it doesn't get so hot.
Yeah.
Cool. Can you put some hot dogs on there and cook a lunch at the same time?
No, this is not boat cooking.
Oh, you have 2 minutes left. We just heard from the judges you guys have 2 minutes left.
Okay.
It is still in autonomous mode. Worked its way around the gate and it's looking for something else to do now. It's making its way towards the docking task. And once again, the docks they only needs to dock in one, and the one it docks in is designated by an underwater acoustic beacon. We can't hear it, but we hope the robot can. Ooh, it looks like it thought about docking, but may have turned a little early. That'll be up to the judge's discretion whether or not they consider that a successful dock. Now it's going right into the obstacle course like it's no sweat. Oh, and it looks like it's tagged one of the obstacles right there. So what do you look for when you get into those obstacles? Are you looking for that blue and orange one in the center?
Yeah, we have looked for the white and black colors, and we have to configure the contrast of the white and black colors and turn something into new colors. Okay.
All right, looks like you're back in manual mode and coming back to the dock. We'll see if that was your last run. I think the judges coming back in the kayaks would be a good indication of that.
Okay.
So we'll see. So did you enjoy this competition?
Yeah, I enjoy because I talk to many people and this is my new experience.
You like the experience here?
Yeah.
Okay. So you're coming back to the dock. Let's see if you guys have time to squeak one more, or if they're going to call this the end.
Okay.
I hear applause, so this sounds like it might have been the end. Well, thank you for talking with me.
Yeah, thank you. Nice to meet you.
Yeah, it was great meeting you. We'll be back with another interview and more RoboBoat action.
Don't worry about it. Don't worry about it. There's enough other eyes on. You should go take a shower. You can get
Okay, second team, Bravo, not kidding.
Yeah, she's not kidding. We don't even know what's in there.
Yeah, I'm not kidding.
All right, we are back at the 2019 RoboBoat Autonomous Boat Competition, and I am sitting here with Hitesh Patel, Director of Robotics Programs for RoboNation. Hitesh, how are you today?
I'm here,
You're here,
tired,
tired,
but we're making great things happen. So
Yeah.
all in all, pretty well. I
but
can't
it's
complain.
worth being tired to put this on for the kids, right?
Absolutely. I think that goes without a doubt.
All right.
No matter what we do, no matter what we go through, to me, it's worth it because our students get the benefit of that.
All right. So throughout the year, you probably have the most interactions with the students as they prepare for this competition. Do you see that there's a correlation between these teams that do a lot of work leading up to the competitions and interact with you a lot, and the ones that kind of don't interact with you until they get here?
Yes, absolutely. And, instead of going into examples, just if I generalize a little bit, teams that reach out to us either on the online forum or through emails about questions they have either on site about the logistics piece or the technical piece or a particular task, they seem to be well ahead of the game when they arrive on site.
Okay.
You've done the safety inspections this week. You've been privy to some of the issues that we've had with the light towers and the e-stops. And those teams that have reached out to us prior to the competition, have communicated with us, interacted with us in some way, shape, or form, they seem to be on point and not have as many issues, I'd say.
Better prepared.
Absolutely.
Okay. Have you, we switched to a big tent. We've seen a lot of team camaraderie from that, and I think we've seen an increase in some of the performances of the team just because we see them reaching out to each other and either giving parts or helping each other out. Would you agree that that's kind of been getting better as this competition gets older?
Absolutely, and it does. And I've seen it take shape from where some of the teams that needed parts and pieces were unaware that that kind of help existed. Now, we as staff encourage that communication by going, hey, don't ask me, go ask this team, or go ask here. So I think to me, that camaraderie continues to increase, and we hope that it continues to be on that path.
Now, I've heard we've seen some new teams this year. What have we seen for this competition when we see these new teams come out?
As far as what goes?
Performance, how they work with other teams.
I think performance-wise, it's more often than not for new teams, it's a different experience. Sometimes it's almost equivalent to a culture shock, right? They're like, oh, we didn't know, we weren't expecting this. As far as performance goes, that's where I would say that falls. Interaction-wise, they're surprised to see the level of friendliness and camaraderie that we encourage, and then the other veteran team seem to have among themselves.
Okay. If we have any potential teams that are looking at joining this competition, watching now, what resources online do you guys offer to kind of help them, A, start communicating with you, and B, maybe also learn some technical stuff about what they need to bring to the competition to be successful?
I think the biggest suggestion and recommendation on that would be to interact with us on the online forum. That is, to me, the one keystone piece that they need to identify and realize that it exists for them, for their benefit. Thereafter, if there are any questions, they can reach out to our communications folks, and then even that communication, when you reach out, eventually gets pushed out to the appropriate people, whether it's technical or logistics. So really, they need to reach out to us in some way, shape, or form, either through the online forum, through emails, or any other contact information listed on our website, whether that be social media or other such portals.
Okay. Well, we just found out we may have some extra time to talk because we just shut down for lightning. So one of the things about, maybe it's the robots that have some luck to it. We also have some luck with the weather. And we just had a lightning strike within 3 miles, so we are ceasing water operations and pausing the clock for Haggerty High School, the last team to compete. So we are under a lightning pause. So I think we're going to pause the live stream for a moment as we also bring down our cameras, because our cameras could act as nice lightning rods, which we don't want to happen. So stay tuned. We'll be back soon as we prepare for this weather that's coming in, and hopefully we'll still get our run in the next, hopefully in less than an hour. So this is Bill Porter and Hitesh for 2019 RoboBoat, pausing for a moment.
Yippee. Take shelter, it's raining.